Let's give SK a welcome hand of applause.
Thank you very much for coming for the session today. Just a quick show of hands. How many of you are real techies who are actually doing coding, especially on the image processing or any type of AI stuff? I'm not going to ask you any questions about tech stuff. Okay, a few. How many of you are pure managers in the technology world? Okay, wonderful. So I have 25 minutes time, and I'm talking about extremely important and vast topic called smart cities. 25 minutes, I think it's going to be very, very difficult for me to do the justice. What I'm going to do is, I'm going to talk about a 30,000 view of how smart cities are done or the architectures of the smart cities, and quickly jump down to the ground level of processing a few of the inputs that's required in smart cities and explain it to you. Even then, I think 25 minutes is not sufficient, but I'll try to do whatever I can. But before I even talk about smart cities and AI, I really want to talk about something non-tech, non-AI stuff. You know, I was reading this, AI is the new electricity, and I'm sure you would have heard of such statements earlier too. AI is the new electricity, or it's like the new fire and all that stuff. I want to actually make a new statement, a different statement. 1830, in the year of 1830, was the first time a patent issued for lawnmowers. Lawnmowers. And the current day $620 billion sports industry has its roots purely from lawnmowers. Can you imagine that? The single source, a single trigger that made a dramatic impact on the sports industry, $620 billion, is from lawnmowers. Initially, before that, there were no playgrounds available for any type of human running, human walking sports. It's all animal-based, maybe like polo and stuff, but lawnmowers actually made a dramatic impact. Also, if you look into the comparison statement of AI as a new electricity, I think it doesn't really bring out the value what AI is doing to the current industry. I think AI, the lawnmower, AI is the new lawnmower, is my statement. It is going to make a dramatic impact on every industry going forward in the next 3 years. My pet statement is, if you are an engineer, if you are a HR person, if you are a finance person, if you could be in any activity, if you don't know AI or if you're not using AI in the next 2 or 3 years, there's a very, very high chance that you will not be employed anymore. So I think that's the tremendous amount of impact AI is going to have. With that, let's start with my presentation. According to the United Nations, the number of cities are going to be dramatically more. By 2030, there's going to be so many more cities. The urbanization is going to be so much. I think the city governments are going to be having additional responsibility to make sure the city life is going to be convenient and safe for every citizen. So we cannot emphasize the importance of urbanization and the consequent technology that need to be used to make it easy. That's on one hand. On the other hand, 2019 is going to be when smartphones will cross 5 billion mark. I'm talking about only smartphones, not even smart devices. Smart devices could be anywhere between 15 to 20 billion counting today, and they're all trying to connect with each other or talk to each other or having information that is worth sharing with other people. And having the, using AI, trying to make sense from completely a data which I think cannot be humanly possible is what is being making possible in AI. I'll give a quick example. Georgia Tech University recently published a paper. They tried to decipher the language of not human beings, language of chicken. Actually, yes, chicken. They found an AI model, they designed an AI model to understand when a chicken clucks and makes different sounds, what's happening in the chicken's mind. Imagine, we can discuss about or debate about the use case of the AI model, but the amount of capability, rather, AI has in trying to decipher and make sense out of this completely unstructured information. There is so much of data in this slide. By the way, someone told me you can't put so much of information on one slide because that's not real presentation techniques. But I'm actually going to put the information there because you can focus on only one section of the presentation, or you can take a picture and then go back and look at it. But this information, for example, on one hand, the number of cities are going up. On the other hand, people trying to use smart devices, the need or the benefit of using smart devices is going up too. For example, this is a survey done by PwC, published I think 2017. The perceived benefits of smart device purchase, it's going up. People are trying to buy more and more, or the hesitation is going down. For example, on the left side, the 42% of the reason why people are not purchasing, if they are not yet, is price. And every year price is dropping. So that hesitation is not going to stop people. I think there will be more and more devices available in the hands of people. Now let me quickly change gears and get into what are the various application scenarios in a smart city. A smart city which million people, 5 million people, 10 million people, there are so many services they're trying to access. Whether it's the traffic conditions, or the safety information, or the healthcare information, or if it's a public safety or public utilities distribution, any type of use case you're looking for. The application scenarios are these. By the way, this is I got this slide from Alibaba. Alibaba is one of the few companies which already has a smart city platform available, which is in production. And a couple of other countries also have done smart city applications. For example, Brazil has done. A couple of Norwegian countries have done smart city implementations. But the number of use cases are innumerable. In terms of voice interaction, facial recognition, image recognition, text recognition, or even NLP, there's so many. We, in my company, we are developing an AI platform for smart cities, and obviously I'll not be talking about the architecture, what we are using, because it's still proprietary, but I can share some of the published information, which has been a great inspiration for us in developing the platform and also in developing the solution for various use cases. Any quick comments you have on these use cases? In terms of the data, you have the volume, variety, and velocity. One missing point or activity is veracity. Sometimes the accuracy and quality of data is another which is really bothering a lot of people. Okay, this is the 30,000 view. Let's get into the quick implementation details. Again, there's lots and lots of information on the slide, but this is a very short, narrow view of how you will architect for processing data online. Now, when I say data, always I mention about the data will be numeric, text, audio, signal, image, and video too. And image and video are two different things. And when I say signal, recently I was presenting in a conference on how Wi-Fi signals could be used to detect human activity. Now, let me contrast that with video image processing. In the last year and a half, let's say 2015 was the seminal year when image processing models, especially with VigiNet or ResNet, crossing the human performance levels. In image processing models today, they can do better than humans. In other words, if you show 100 images, the average error rate of a human being is around 5 to 6%. The average error of an image processing model is only 3.6%. What does that really mean when you can say you can do better than a human being? What it means is, if an image is blurry, cannot be really seen well, cannot be understood by a human being, a model can easily understand. So next time when you don't want your pictures to be seen by other people, oh, I'm trying to do some jittering of the model, I'm going to send it across online, don't do that. Because if the model sees the pictures, it will figure out what you're trying to say. But in 2015 has been a seminal year for image processing. The number of layers, number of parameters, the amount of memory it takes. But all of these image processing models have three fundamental problems. One is privacy. People don't want pictures to be taken. Number two, darkness or light. if you're trying to apply the image processing model in the context of a healthcare situation, the patient are trying to monitor a patient, but the patient is sleeping and you can't see because it's lights off, so the model actually won't perform. Third and the most important thing is, it's called line of sight. Unless the person who's being monitored is not in the line of visibility of the camera cannot, or the model cannot function. To address all of these three situations, there is a research going on today, and I think this research is such an infancy that it is not come into production level. I know a few networking companies have been working on. Of course, it's in the academic world. Commercially off-the-shelf routers are being used, or router signals are being used to detect human activity. There are papers published, I don't have them in the presentation today, but there are papers published where it can track lip movement, it can track even the keys you are striking on your keyboard. It will track, of course, basic human activities, let's say in a healthcare situation. Are you standing? Are you sitting? Are you falling down? Are you sleeping? Are you breathing? All of these activities are being tracked. Of course, it only applies in an indoor situation because you're going to be using Wi-Fi signals in an indoor situation. But the point I'm trying to make is whether it's audio, video, image, numeric, text, and signal. All of these data need to be captured and processed. And some of the data is coming intermittently, some of the data is coming continuously in the stream. Having a robust architecture which captures the data, stores the appropriate amount of data, discards which is not required. All has to be thought through. If you look into this architecture, I have mentioned the paper I've got this from. On every slide where I've got the information, there's a link to the paper at the bottom. You can go and check that. This complicated architecture talks about how you're processing the data online. And this is not even talking about fog computing or edge computing. This is talking about just online cloud computing. Next framework, next architecture I want to talk about is the text processing. We are developing right now a platform which does data pre-processing. It's actually in beta testing right now. And when I say data pre-processing, let's say you're a retail company, let's say you're a transportation company or a healthcare company. You have lots of data that's coming in. And you want to use the data to develop a new neural model which will address a specific use case. Let's say your marketing comes and says, you know what? All millennials seems to be curious about this new toy that has come in. Can we develop a new app that creates new types of images of this toy and show it? In any artificial intelligence, especially a deep learning model, in my personal opinion, 80% of the effort is spent on just data processing. And when I say data processing, checking the data, availability of the data, sparse data, incomplete data, wrong data, all of those stuff. Putting together, it's almost take 80% of the time. And then of course designing the model maybe another 5-10%, and then training the model the rest of the time. The platform we are developing, of course, is free processing the data. For example, if you are a satellite company taking lots and lots of images of Earth, there is a company in San Francisco which takes 500,000 images per day of Earth. And what's the use of the images? You can give the image to, let's say, a transportation company, a shipping company, and they can figure out when the ships are going to be arriving at the destination. If you are a government, you can find out the status of the wildfires or floods or just the deforestation or the reforestation activities. Or let's say if you are I talk about transportation, let's say you are a retail company, you want to find out how many people are visiting my brick-and-mortar stores in various locations in the country, and what type of people. You actually can have the satellite image of the parking lots taken and evaluate the number of the cars and the types of the cars. So the platform, this is one such platform which actually talks about how to pre-process the data. Another platform I want to talk about is the streaming, data streaming infrastructure architecture. For example, I don't know if you can see my laser pointer here. You have a bunch of sensors that's inputting data, that's transmitting all the time. Now you have a single server or multiple servers, which you implement on the cloud, all that they're doing is collecting the data, identifying what's the right amount of data, and then keeping it. And of course, there's a load balancer before to make sure where to direct the data that's coming in. Now, these sensors cannot be completely dumb sensors where they create the data and transmit it to the servers. There has to be some computing happening. So many of these smart sensors that's coming in, they process the data to some extent. They actually can decide which data to be kept, which data to be discarded. Number one. Number two, which data could be kept for a short time and which data need to be kept for a longer time. Also, many of these sensors, you need to have information about the location and other time stamping too. Once you have these collectors that collect the data, then you can put it in the main server, which actually acts as the sole supplier of all the data. And from there, you can identify part of the data that can be made accessible to third parties who can use that as a public API. Now, why do you need to do that? In a smart city situation, you also have not just the time or geolocation information, but also have some personal, sensitive, confidential information that's being shared by the city. For example, there are a couple of cities in the United States which are disbursing social security funds to people who are in the need or who deserve those funds. In that situation, or if you are trying to give information about the Medicare and Medi-Cal details to the patients, you are having access to those sensitive information about the individuals, including the name, gender, age, medical situation, social security numbers, and stuff. So from the mainstream, you try to filter the information that's only to be given out to the third party into a different server. Some of this data that's coming in can be processed for a short time, and then once you get the essence out of it, you can throw away the rest of the data, whereas some other data need to be kept for a longer term. For example, when you do Google Waze mapping, you want to find out when you can reach, when you give the destination and the starting point, it will tell you what time it's going to take if you start now, but you can also ask Google Map, okay, if I leave at 6 a.m. in the morning tomorrow, how long is it going to take? And that information, that type of questions could be answered by having some of the information or some of the essence of the information stored for long-term services. So this is just a quick view of the architecture that you need to plan for when you're doing the data streaming. Now let's get to the real details. In smart cities, one of the huge use case is video management. There is lots and lots of videos that's coming in. You actually have cameras, they're streaming live video. You can use these cameras to take images, that is, you can take a snapshot at any specific time and then use that for processing to find out what's happening, maybe classification, segmentation, detection, localization, whatever it is you can do. But you can also use the video itself to process. I will talk about in a different slide how to process a video. Now, in the last year and a half, I think 2016 and good amount of 2017, there were a lot of research published on how to process an image. Not as much reports or research on video processing. So if you have a still image, you can find out what's happening in the image. Is there one cat or two dogs, or is the traffic light red or yellow? You actually can do visual question answering, all of that stuff too. And that's only on the images, but video processing is not that. But before you can even do the video processing, you've got to capture the right amount of information in the right format. For example, if you have, let's say in a city like San Francisco has maybe even close to 1 million cameras, if 1 million cameras are producing every 1 hour, you actually have 1 million hours of video being transmitted. And if you transmit all of that to the central server, first of all, you will have multiple servers, and you will have a wide bandwidth of network required. But majority of that data is not required, so you can have the fog computing going on, or edge computing going on, where the cameras can decide what information that need to be preserved or transmitted. So there's some amount of, you have the raw video which is being imported, so you actually have compressed video being sent across in the net, but also you can do some feature extractions. Feature extraction can be as simple as just a timestamp or the location, geolocation, or it could be some sort of a classification details of the image. So you can actually take a frame on a specific time and then detect what's in the frame and pick maybe a 10th frame or the 100th frame after and do a similar activity. Do a feature extraction, compress that, send it on the network, and decompress and then store it into the systems for feature processing. There are 3 or 4 major use cases in video. So you have the person re-identification, vehicle re-identification, and of course the other 2 ones, the face recognition. A university in Israel 6 months ago published a very interesting paper on image processing. And that is, the actual paper is titled called How to Bring Your Picture Live to Life. Let's say you take a picture with modern cameras, modern cell phone cameras. It takes a couple of milliseconds before and a couple of milliseconds after, so it gives an impression of a live situation. But that's, you're taking a live picture. But what if you have taken a picture which is still, and you want to bring it to life? In other words, you have a still image where the person is looking with a serious face, and you want to put a smile onto the picture. Or you want to make the picture wink at you. Or the picture even laugh at you. So this university is Israeli university in collaboration with Facebook. So I would not be surprised in 6 months from now when you log into your Facebook or let's say your friend's Facebook. If it's a friend, maybe the picture will smile at you. If you are the spouse, maybe it will wink at you. If you are someone else, it will do something else. But all of those activities the picture can do. So that's just the next step of face recognition. But that's Facebook or any other place. Let's say you have an iPhone. I think iPhone 10 actually has a facial recognition where you can unlock the thing too. But in all of those use cases, the model knows who you are. Right? In smart city situation, the fundamental difference in a face recognition is model has never seen you. You are a city official trying to find, okay, this person is a person of interest. Now I want the model to tell me, okay, where was this person yesterday? Out of the 1 million cameras in the city, you will be running a detection algorithm to find the same person from all of those 1 million times 24 hours times whatever. That's the complexity I think I want all of us to recognize. So that's the person re-ID. Vehicle re-ID. The most common way of detecting a vehicle is you just do a number plate recognition. Just have a model called YOLO. I'll talk about YOLO model in a minute. But Mike, there's some time. Okay, Mike is not here, so I can always we lock the doors, guys, so you can't go anywhere. Yeah, and we already have pizza, so I think. Mike, how much time I have?
Done for a minute.
Couple of minutes.
We'll have 5 minutes for Q&A.
Okay.
How close are you?
Wait, I'm not close. I'll try to make it fast. Vehicle re-identification is if you don't have access to the number plate, or sometimes the number plate could be fake too. That is, how do you ID the vehicle? That's another activity you can do. This is a very specific implementation of, if you take a still image, you can identify the number of cars in the parking lot. YOLO 1, YOLO 2, this model, YOLO 1 came out I think in 2016, YOLO 2 came out in 2017, YOLO 1 actually had a performance of around 45 frames per second FPS, and YOLO 2 has 224 FPS. So in other words, it can actually detect live, even though it's processing frame by frame, which is being used in autonomous cars nowadays. So you actually can hold up your YOLO model on your phone, and if you swipe it, the phone across, it will actually start identifying each one of you. So next time you think no one is watching you, think twice. The camera knows exactly who you are. So I don't know how many, if you want me to get into the details of the CNNs, but if you look at the CNN model there, you have a bunch of convolutional layers and pooling layers and eventually I think an FC layer, fully connected layer, which actually does the classification. So from a massive picture, it actually does the localization and detects the cars alone, and then it actually counts the number of cars in it. Radio-based approach for traffic detection. Traffic flow, if it is just the number of cars, it's the easiest thing. You can have a transmitter and receiver on both ends, and every time the signal breaks, that's one car. But, but in a smart city situation, you want to find out what type of car it is. Was it a truck or a van or a bike? So it actually does classification. It actually tracks the signal and does a classification of it. Again, if you want to get into the details, there's a paper there. But these are all being implemented in the smart city solution we are trying to work on. This is the face recognition I talked about when you have on the left side the traditional model where the model has seen your photo once and now it can recognize. So when you when you create a Facebook account, then the model knows who you are. And next time your friend has taken a picture of you and uploaded it into their account, still the model knows where you are and it'll immediately tags your face. But in a smart city situation, the model has never seen your photo and hence it has to find out. And they do have extremely good accuracy rates measured in video analyzing. When you have, let's say in a video, there is you have a camera, surveillance camera, which is tracking, and there is a crime currently happening. How does the model know there's a crime happening? It has to analyze frame by frame on a spatial and temporal on the temporal axis to find out the changes that's happening from frame to frame, and then make a classification based on each frame. And more details can be found, but if you look into the size, the architecture of the model, there is, I think it's a bunch of layers of convolution layers, and of course they have the decon layers too, where they're trying to first in convolution layer compress the image, and later on they're going to expand the image. I'm going to quickly get this.
Thank you so much. Thank you.
That's it.